Right now, on the other side of the planet, in a place almost nobody watching this will ever set foot on, the last piece of ice holding back one of the most dangerous glaciers on Earth is starting to break apart. Scientists who have spent years monitoring it are using words like poised to disintegrate and calling this moment the glacier's last act. This isn't a prediction about something that might happen decades from now. Researchers say it could begin as early as this year. And here's the part that should really get your attention. The ice breaking apart right now isn't even the dangerous part. It's what happens after it's gone that scientists have been quietly dreading for years. I'm your host, and this is Verge. If you're new here, this is exactly the kind of story we dig into, the ones where a single, specific, measurable event quietly crosses a line that changes everything that comes after it, even if most people never hear about it happening. Stay with me, because by the end of this video, you're going to understand why a chunk of floating ice breaking off the coast of Antarctica could matter more to your own life, wherever you live, than almost anything else happening in the news this year. Before we get into it, go ahead and subscribe, because this is just the beginning of what we're covering, and you don't want to miss where this goes. Let's start with the glacier itself, because you need to understand exactly what we're talking about before any of this makes sense. It's called Thwaites Glacier, and it sits in West Antarctica, one of the most remote and hostile environments on the planet. It's more than 2 kilometers thick in places, and by itself, it holds enough land-based ice to raise global sea levels by roughly 65 centimeters, a little over 2 feet if it were to fully melt. That number alone should be startling, but Thwaites isn't dangerous just because of what it holds on its own. It's dangerous because of what it's holding back. Thwaites acts like a cork in a bottle for a much larger section of the West Antarctic ice sheet behind it. If Thwaites destabilizes enough, glaciologists warn that it could open the door for significantly more ice from that larger system to flow into the ocean over time, which is part of why researchers gave it the nickname that's stuck for years now, the Doomsday Glacier. Since 2018, an international team of scientists from the US and the UK, working together under something called the International Thwaites Glacier Collaboration, have been studying this glacier using ice-breaking research ships, satellite data, GPS sensors frozen directly into the ice, and even an underwater robot named Icefin, specifically built to swim beneath the glacier and film what's happening in places human divers could never survive. And what they've found over these years of study is genuinely more alarming than the nickname alone suggests, because Thwaites isn't melting the way most people picture a glacier melting. Here's the picture almost everyone has in their head, and here's why it's wrong. Most of us imagine glaciers melting the way an ice cube melts on a countertop, slowly shrinking from the top and the edges as the air around it warms up. That is not what's happening to Thwaites. Thwaites is melting from underneath. Much of the glacier sits on bedrock that's actually below sea level, and warm, salty ocean water has been finding its way underneath the ice, eating away at it from below, completely out of sight, in a process almost no satellite can directly observe from above. Researchers using that underwater robot found visual evidence of warm water pushing beneath the glacier, and more recent tracking has shown tides are pumping that seawater more than 6 miles, over 10 kilometers, underneath the grounded ice itself. That's not a slow surface melt. That's an entire ocean quietly working on the glacier's foundation from a direction nobody can watch happening in real time. And here's where the story gets genuinely strange, because when researchers went digging into the glacier's geological history to figure out when this retreat actually began, they didn't find a recent starting point tied to modern climate change alone. They found evidence that Thwaites' retreat likely began back in the 1940s, and the leading theory is that it may have been triggered by a powerful El Niño event, a natural warm ocean climate pattern, decades before most of the warming we associate with today's climate crisis had even taken hold. Think about what that means for a second. A shift that started roughly 80 years ago, quietly, deep beneath the ice, is only now, generations later, reaching the point where scientists are watching its consequences play out in real time. This glacier has effectively been on a slow-motion collision course for longer than almost anyone alive today has been watching it. Now, here's the detail that makes this year specifically important, and it's the reason we're talking about this today instead of at any other point in the last several years of research. For a long time, part of what has been slowing Thwaites down is a floating extension of ice attached to its front, called an ice shelf that acts like a natural brake, physically pushing back against the glacier and helping hold its flow in check. Most of that shelf has already broken apart over the years, but there's been one last remaining section, the eastern ice shelf, that has continued clinging on. And according to Robert Larder, a marine geophysicist with the British Antarctic Survey who coordinates the UK side of this research collaboration, that final piece is now poised to disintegrate. Researchers studying the ice say they genuinely don't know exactly how it's going to break apart, only that it's definitely going to happen, and it could start as early as this year. A separate peer-reviewed study out of Cambridge University has described this moment plainly, calling it the ice shelf's last act. I want you to sit with that phrase for a second, because it's not dramatic language chosen for a headline. It's a scientific description of a genuine turning point. The last natural break on one of the most consequential glaciers on the planet is coming off in real time in the same year you're watching this video. It's worth slowing down on that underwater robot for a second, because the way scientists actually gathered this evidence is almost as remarkable as what they found. Icefin isn't a simple camera on a cable. It's a slim, torpedo-shaped robotic vehicle, engineered to be lowered through a narrow borehole drilled directly through hundreds of meters of ice, and then to swim freely underneath the glacier in near total darkness, mapping the underside of the ice and the seafloor beneath it in places no human being could ever physically reach and survive. Getting Icefin into position at all requires a research team to camp on the ice sheet itself, melt a hole through the ice using hot water drilling equipment, and lower the robot down into water that sits just above freezing in complete darkness more than half a mile from the nearest ship. The footage and sensor data that came back from those dives is what gave researchers their first direct visual confirmation that warm ocean water was actively flowing beneath the glacier, rather than something inferred purely from satellite measurements and computer models. In a field where most evidence comes from instruments in orbit hundreds of miles above the ice, actually sending something underneath it to look directly at the problem was a genuine turning point in how confidently scientists could describe what was happening. Thwaites also doesn't exist alone out there, and understanding its neighbor helps explain why researchers are watching this particular stretch of coastline so closely instead of treating Thwaites as an isolated case. Right next to Thwaites sits Pine Island Glacier, another major outlet, glacier draining ice from the same broader West Antarctic ice sheet, and one that has been retreating and thinning for years as well, driven by many of the same warm ocean currents undercutting it from below. The two glaciers don't operate in complete isolation from each other, because they're both essentially drainage points for the same interior mass of ice sitting further inland. When researchers talk about West Antarctica as one of the most closely watched regions on the planet for long-term sea level projections, it's specifically because you have multiple major glaciers along this same coastline, showing similar warning signs at roughly the same time, rather than a single unusual outlier that might just be a local fluke. And I'd genuinely like your answer in the comments. Before today, had you ever heard of Thwaites Glacier by name, or is this the first time this specific piece of Antarctica has been on your radar, I ask, because most people I talk to have heard the phrase Doomsday Glacier thrown around somewhere in a headline or a documentary, without ever actually knowing which glacier it refers to, or why scientists gave it that name in the first place. Now, let's be clear about something, because this is exactly the part where a lot of coverage of this story tips over into exaggeration, and I don't want to do that to you. The breakup of this floating ice shelf will not, by itself, directly raise sea levels in any meaningful way. That's because the shelf is already floating on the ocean. The same way an ice cube floating in a glass of water doesn't raise the water level when it melts, since it was already displacing that water while it floated. The real danger isn't the shelf breaking apart. It's what the shelf was doing while it existed. It was pressing back against the grounded glacier behind it, acting as resistance, slowing down how fast that land-based ice could flow toward the ocean. Once that resistance is gone, glaciologists expect the glacier behind it to speed up, flowing and calving into the sea faster than it has before, and that ice, the ice that's currently sitting on land rather than already floating, is the ice that actually adds new water to the ocean when it eventually ends up there. This is where a concept called marine ice sheet instability becomes the center of the whole story. And once you understand it, you'll understand exactly why scientists are so concerned about the geography of what's happening here. Thwaites doesn't just sit on a flat seafloor. Much of the bedrock underneath it actually slopes downward as you move further inland, away from the coast. That means as the glacier retreats and its edge moves backward, the ice at that new edge sits in deeper water than before. Deeper water means more contact with warm ocean currents, which means faster melting, which pushes the retreat even further back into even deeper water, in a feedback loop that tends to accelerate rather than stabilize once it truly gets going. That's the mechanism researchers are worried about. Not a single dramatic collapse, but a self-reinforcing retreat that gets harder to slow down the longer it continues. And the data on how fast this is already moving is not subtle. A modeling study published this year found that Thwaites' rate of ice loss has increased more than fivefold since the 1990s. Separately, other research projecting the glacier's trajectory forward estimates it could be losing somewhere between 180 and 200 billion tons of ice per year by 2067, an amount that would meaningfully affect global sea level on its own, decades before the glacier anywhere near fully disappears. To be fair to the science here, and this matters, the same international collaboration studying Thwaites has concluded that a complete, sudden disintegration of the entire glacier in the next few decades is unlikely. This is not a doomsday clock ticking down to a single catastrophic event next year. But that same research is clear that the glacier's retreat will continue and it will accelerate, and the loss of this final ice shelf is one more piece of evidence pointing in exactly that direction. Here's the part. Almost nobody explaining this story stops to actually spell out for you, and it's the part that connects all of this back to your own life, no matter where you're watching this from. If Thwaites were to eventually melt completely on its own, that alone is enough to raise global sea levels by around 2 feet. But scientists are far more concerned about Thwaites' role as a stabilizing plug for the broader West Antarctic ice sheet sitting behind it. If that larger ice sheet becomes meaningfully destabilized as a result of Thwaites losing its grip, some estimates for total potential sea level rise from that broader collapse run as high as 10 feet. That is not a number that stays confined to Antarctica. 10 feet of sea level rise reaches directly into the lives of people living in coastal cities like Miami and low-lying regions around the world, including Bangladesh and Pacific Island nations, that could face existential threats to their entire landmass. It reaches London. It reaches every coastal city built on the assumption that the ocean would roughly stay where it's always been. To be responsible with this information, none of that 10-foot scenario happens next year, or even in the next decade. This is a process playing out over generations, not headlines. But the reason scientists study small, specific moments like an ice shelf's last act so closely is exactly because processes like this are much easier to slow down early than to stop once they've built up momentum. And once a system crosses certain physical thresholds, glaciologists genuinely don't know how to reverse it using anything currently available to us. That's the honest, unglamorous truth sitting underneath every dramatic headline about this glacier. We're not watching a single doomsday event. We're watching the early, measurable stages of a slow-motion shift whose full consequences will be inherited by people who are children today or not born yet. There's one more layer to how scientists actually track a glacier this remote day to day, and it matters because it explains how researchers can confidently say ice loss has increased more than 5-fold since the 1990s instead of just guessing. Satellites equipped with radar and laser altimeters have been measuring the surface height and flow speed of Thwaites for decades now, essentially timing how the ice sheet's elevation and movement change year over year from orbit. Other satellite missions track tiny shifts in Earth's gravity field caused by the sheer mass of ice sitting over Antarctica, allowing researchers to estimate total ice mass loss across the entire continent, not just at Thwaites specifically. Combining that orbital data with GPS sensors, physically frozen into the ice on the ground, and now with direct underwater observations from vehicles like Icefin, is what allows scientists to move from vague concern to specific defensible numbers like the ones we've been walking through in this video. This is not a story built on one dramatic photograph or a single alarming headline. It's built on multiple independent streams of evidence from space, from the ice surface, and from underneath the glacier itself, all pointing in the same direction. And that consistency across independent methods is exactly why this particular piece of research carries real weight, instead of just being another scary headline about climate change in general. It would be easy to hear the phrase Doomsday Glacier and assume it's media exaggeration layered onto a slow, boring process. It isn't. The specific mechanism at play here, warm water intruding kilometers beneath grounded ice, a final ice shelf acting as the last mechanical resistance before that intrusion accelerates unchecked, and a seafloor shape that makes the whole process self-reinforcing once it gets going, is about as well documented and specifically understood as any large-scale glacial process currently being studied anywhere on the planet. And understanding where it fits into the bigger picture of Antarctic research actually makes the stakes clearer, not more abstract. Thwaites sits alongside several other major glaciers along the same coastline of West Antarctica, and researchers studying the region have increasingly treated this area as one of the most consequential pieces of ice on the entire planet when it comes to long-term sea level projections, precisely because of how much ice sits on land here rather than already floating in the ocean. Land-based ice is the ice that matters most for future sea level rise, because unlike floating ice shelves, it isn't already displacing ocean water. Every ton of it that eventually slides into the sea is a ton of new water, added to a system that coastal engineers, city planners, and insurance companies around the world are only just beginning to fully price into their long-term models. And that's really where this story becomes less about a distant glacier and more about decisions being made, or not made, right now, in cities you might actually live in or visit, coastal infrastructure planning, flood defense systems, insurance risk models for waterfront property. All of it depends on assumptions about how fast sea levels will realistically rise over the coming decades. A finding like this year's ice shelf collapse doesn't just belong in a science journal. It's the kind of data point that should be feeding directly into how seriously those systems plan for a coastline that won't stay exactly where it's always been. Here's the piece of this I think deserves to sit with you the longest. This entire process, the one culminating in a headline you might scroll past this year, began roughly 80 years ago, quietly beneath ice. Nobody was watching closely at the time, triggered by a single powerful climate event most people alive today have never heard of. It has taken decades of slow, invisible momentum, hidden beneath a glacier in one of the most remote places on Earth, to finally produce a moment scientists are willing to describe, using words like last act and poised to disintegrate. That's the uncomfortable truth about processes like this. They rarely announce themselves with a single dramatic moment you can point to and say, that's when it started. They build quietly for decades until one specific, measurable threshold finally gets crossed, and by the time it's obvious enough to make headlines, the momentum behind it has already been building for most of a human lifetime. If this kind of story is exactly what you come here for, subscribe and turn on notifications, because we're going to keep tracking exactly what happens as this ice shelf breaks apart and what researchers find once it's gone. Let me know in the comments. Does knowing this started decades ago before most of today's climate conversation even existed change how you think about it? Or does the timeline not really change how seriously you take it? And if you know someone who lives near a coastline, or just someone who'd genuinely find this as fascinating and unsettling as I did putting this together, send them this video, because understanding what's actually happening at the bottom of the world matters a lot more to the rest of us than most people realize.